Welcome to B-Side Splunk 2022. I'm speaking to you today from Turkey with a beautiful view on a Greek island on this side and to Turkey on this side. And it's the best presentation location that I actually ever had. Even Vegas wasn't that good. I'm on vacation and therefore I will record it from here. Great to see you all. And let's directly dive into the topic. I've been talking at SplunkConf 2022 with my colleague Johannes about mastering index sizing and configuration, and I thought it's generally a good idea to extend that to the specific or special little metric store, where it seems to me that it's a really undervalued technology and capability within Splunk. And luckily I had the opportunity, not too far away in the past, for a customer to check compression and performance. And especially compression is a topic for me as an architect, and sizing different environments for different customers, where we want to understand how much data is stored on disk per 1 million data sets, per 1 million metric points, basically. If you want to see the previous talk from .conf, it is available at Conf Online on the Conf archives. Should be by now available as well for free for everyone. Check it out, and we move into the metric store topic. So first, quick agenda. I won't read that out. I think that's obvious, right? We start with who I am and what the metric store is. Move over to how to configure and what I did for flow testing, some problems and how we fix that, and then we come to some QA. That's me. My name is Oliver Hoppe. I'm a Splunk Trust member. I run different Splunk user groups across the globe, support different user groups as well, try to be really active in the community. If you haven't joined the Splunk community yet, community.splunk.com. There's as well the possibility to join our Slack channels, which is, I think, for me personally, the most important bit in the community, because there you get your questions really answered and can have a good discussion. Beside that, in my professional life, I'm a lead architect and data strategist at LC Systems, and take care of my kids as a, let's call it, hobby. So what is a Splunk metric store? It was released with Splunk 7.0 back in September 2017. As you guys all know, the log index, basically, where you put in your logs, and most likely pretty often have pushed in logs that contain metric events in the end. Splunk had decided back in 2017 to release a dedicated metric store, which was for me personally amazing. I used it quite often. Unfortunately, out in the field, I think, as I mentioned earlier, it's quite underestimated, because it's easy to get metrics in, it's easy to get them out, and you can combine them with any logs on your dashboards, right? And they are by far faster, and I think they take way less storage from my point of view, for the information that they give you. Even metric information is, by its cardinality and volume, by its sheer volume, just not as a log, right? It's not used for investigations by the single log line or by the single metric. It's more like by the statistical findings and trends that you find out where it becomes really interesting. The Splunk metric store today supports two main formats for metrics to be ingested, which is statsd and collectd, but you can ingest any other kind of metrics via a universal forwarder if you format it correctly, or via the HTTP event collector. Multi-metric support, it has been built in, I think, in 8.x. Let me not be too specific here. And there are some capabilities to convert logs to metrics at ingest time via heavy forwarder or via the indexes themselves, right? The metrics that will be or are searched by some specific or special commands like mstats, mpreview, and mcatalog, so you are not able to use your normal stats command or index equals foobar, right, my data time chart x. That's not how it works, but generally it is straightforward. It's a steep learning curve, nothing to be concerned about. And there's as well to learn about the datasets tab. No, it's not datasets, analytics workspace tab inside your Splunk deployment, where you can take a look at the internal metrics of Splunk on the underscore metrics index, where Splunk is basically storing its own metric data. So as I mentioned earlier, what's driving me is mainly sizing activities, right? And problems that you might meet up the way when implementing a metric store, different metric indexes, right, in Splunk. And first, before we go into the load testing that I did, let's quickly talk about how we can configure the metric store. Via UI, that's easy, but as you all know, for normal indexes, it's quite limited in regarding the specific configuration. For a normal test on a single box, yeah, do it via UI. On a distributed deployment, you obviously do it via indexes.conf and deploying it via the leader bundle, right, via the manager bundle. There are a couple of settings which are quite specific, which we should quickly walk through. It is a normal index stanza that you define in indexes.conf, but it needs the setting data type equals metric. Without that, it won't be a metric index. There is a specific setting which is as well available via the UI, which is timestamp resolution, seconds or milliseconds. Be aware that milliseconds resolution has a massive impact on compute, right? So therefore, most likely you won't need it. Default is seconds. Stick to seconds if you don't know what you're doing. Then, like for normal log indexes, we have settings like max hot buckets, which is usually set to auto, which is then following the normal max hot buckets of log indexes, which is as well set to auto, which then is 6 hot buckets at a time. You can increase that if that's really necessary, but that's a different story where you would like to look into what is a good reason why you would have more hot buckets. That usually comes by the next setting, when you want to split by other index keys, like for example source type, etc. Can be all looked up on docs.splunk.com as usual, which is quite informative to check out. So what did I do? I wanted to understand how the metric index is performing regarding compression, as mentioned. And I thought, hey, let's just simulate with a data gen 5,000 hosts. Let's put a bunch of different metrics in, 68 different metrics, multi-dimension metrics. So a single metric event could contain up to hundreds of different things. For example, netstat, which contained any kind of netstat, TCP, UDP, socket stats, whatever. Others just contain 1 or 2 different metrics or metric names. But ingested initially 68. And I simulated a huge variety on the values, right? Everything was limited to 2 digits precision. But some values I wanted to really mimic the real world, right? So where something like a TA is gathering something like bytes, 3 bytes on a disk, right, for your disk stats. As it's bytes, the range really ranges from 1 byte up to billions of bytes, right, in order to reflect the real world. And that, of course, gave me some problems in the end. I will come to that in a second. Later, I reduced that to 46 metrics, so I had a second run, because the first one showed me some problems, which we'll discuss in some minutes, which were mainly limited to memory and CPU, right? And as I mentioned earlier here already, the netstat metrics were removed because they contain hundreds of different metrics within a single netstat one, and that was mainly killing with its with a variety the buckets themselves. As said, I come to that in a second. So the first run that I did, that I mentioned here, with 68 metrics, I found that I have a compression after rolling hot to warm, which is important, right? Hot is not optimized, right? The warm compression was between 300 and 1000%. In real numbers, a single gigabyte of metric data ended up as 3 up to 10 gig on disk, and was just like, wow, that's way too much. What's happening, right? And I never had that problem. And I know that some of my colleagues, the Splunk Trust, had that topic earlier, but I wasn't aware about. So that's where I searched Slack, basically, and quickly found out that my problem is 2 things. Strings data, together with max meta entries, I explained that in a second, and max warm DB count. So strings data basically contains pointers of your metric names and values, right? And as a metric index is not containing any raw journal here, it basically is all in TSIDX, and somewhere you need to get the values from, right? So what happens is that by default strings data has a setting, I think, of 1 million entries, and then it's starting to roll. So what's happening is I was shooting, the volume in the end doesn't matter, but I was really generating up to 500,000 metric points per second, which is not uncommon in normal scenarios out in the field, right, for our customers. And the max metro entries then was overflowing, and basically a hot bucket got rolled to warm. And once I was hitting 300 warm buckets, it was rolling to cold. So I never hit the limits of warm, sort of home pass storage size that I had configured. And I was quickly rolling over to cold storage, and it was just like, oh wow, that was unexpected, let's say, right? Then I did a second run in order to reduce the amount of entries in strings data, which was mainly then, as said, reduced to memory and CPU. And there I got to numbers of compression that were, let's say, acceptable. And I was running out of time before moving on vacation here, basically. But what I can tell you is 95% to 150% compression is what I got out of it, and I think there's still a way to go to get it even further down, especially with some recommendations that I will make in the end. Testing is ongoing. I'm happy to update the slides once I did this. There's a talk out there which I link later on in the slides by two of my colleagues from the Splunk Trust, but generally there are some recommendations how to improve that compression even further. The second run then, the buckets were far later rolled to warm, right? And then to cold because of smaller strings data and max meta entries, and therefore later hit max warm dB count, which is obvious, right? There's nothing to be discussed here. But I think it's quite interesting because the longer you can keep a single bucket open, a single hot bucket open, it means you can have better compression, right? Because the names, the cardinality is not exploding, let's call it like this, right? All the metric names and the metric values become more and more often duplicates, which is good, right? So instead of having multiple entries for each and every value, especially as I said earlier, when you have digits in the range of 10, 15, 20 digits even, right, of a value, then that becomes a problem. And the more often you hit the same value, the less storage it takes to add that entry, because it's just a second mark that this was happening twice just at a different timestamp, right? And therefore compression is going further down. Just listing here the problems that I found. As said earlier, the buckets roll too early, independent of max data size because of strings data, and the compression is quite bad. So how do we overcome those problems? Right? First, we need to understand how we, and that I explained that a slide later, how we can find out about compression. I will explain that in a second. That's as well available in Johannes and my talk from .conf about normal indexes, right? So there's REST API and DB inspect that you can use for that purpose. But the general recommendation, if you want to use metric store excessively, and I mean you are having an environment with thousands of different hosts generating a huge amount of different metrics, right? My first recommendation is remove precision where it's not required. Do you really care about if a CPU is running on 86.45% or on 86%? I think the latter one, most likely. Removing that kind of precision is having then just 100 different values for that particular metric instead of 1,000 particular ones, right? So removing precision makes sense, or at least reducing precision where it's possible and hardly needed. There are different ways to do that. You can use propsconf transforms, right? There are now ingest eval commands available at Splunk in a Splunk deployment that you can use to do all of that. Just keep in mind, if you see that your buckets are rolling quickly, removing precision can be really one of your solutions. Then the next one would be the next recommendation, and I tested slightly with it, and I've seen an increase of bucket sizes by the factor of 5 to 10. So instead of logging bytes in your metrics or kilobytes, go as big as you need it for your day-to-day business. As an example, do you really care if your server that has a 100 terabyte disk in, right? Or just 4 terabyte disk? Listing that in max is usually sufficient for proper monitoring, right? So if you just list it in max, let's stick to the 4 terabytes here. 4 terabytes in bytes would be a way more digits to be stored compared to megabytes. So from bytes to megabytes is basically 9 digits less, right? 3 by 3. And that is an amazing improvement in order to avoid that your buckets are rolling and that your strings data is overflowing, and therefore your compression will get away better. As said, I tested parts of that already. It's not done, it's not scientifically proven yet, but there's clear evidence already that this is making a huge difference. As said, do you really need to know how many bytes your disk has free? No. If you have 4 terabytes, you're interested maximum into the in max. What is the max that your disk has free? Then there's one more finding, and that's exactly why I did the second run. Do not send too many different metrics into the same index. I know different environments, different customers have different requirements. I understand all that. Segregation of data is a huge topic for all of you, but for my findings, it makes sense to have, for example, in a metric index for CPU data, for CPU metrics, one for memory metrics, one for network metrics, and one for whatever, right? Other metrics, whatever they are. And that way you can as well avoid that you have too many different entries, or an exploding cardinality, basically, that your strings data gets bloated inside a single index, right? If you need segregation, I know it's a topic of having too many buckets in a especially clustered environment, but it's worth to take a look at least if a segregation into different indexes makes sense first for the different metric data sets, and second, if you then really need a further breakdown into per customer, per internal customer. If you're an MSP, per external customer, okay, there I can clearly understand it. But internally, how important is metric data from a security point of view? It does not contain PII. Yeah, it can be sometimes confidential because you might have dimensions in like IP addresses and host names. Okay, I get that. But on the other hand, how far exposed is your Splunk environment out there, right? So that is clearly a topic that you should look at in order to limit the problem that I was describing earlier, right? Rolling buckets too early. I tested a bit with increasing max meta entries, and I just put that out as a disclaimer right now. Don't play around with max meta entries unless you really know what you're doing. It is possible to do that by index, that's fine, but if you do it on your prod, I increased max meta entries from 1 million to 10 million, and it had a significant impact on CPU and memory. Because what Splunk, the Splunk daemon basically needs to do, it needs to keep that in memory and needs to insert all these pointers into that file. And it's a huge difference if it needs to do that onto maximum, worst case, just closely before the file is rolling into 1 million entries or into 10 million entries, right? So be really careful with that. Slightly increasing it, I don't see any problem. As said, I played around setting it even to 10 million entries. My environment was surviving, but honestly, it was not doing anything else except metric testing here. So I was not putting anyone on risk, right? But it's worth to take a look if you really want to dig into the topic. Then, the most important finding from my testing is, and that's what I need as an architect in order to give a customer the explanation, hey, if you size the environment and you know that you have X amount of metric points per second, 1 million metric points with my testing ended up as roughly 20 megs on disk. I used a standalone instance, AWS with NVMEs, right? So I removed all bottlenecks on compute and I/O weight. But if you have a clustered environment, you obviously need to include possible replication into your calculation. I think there's more space for improvement here. But that's something that I'm happy to follow up with you guys on Slack, right? I'm happy to share any numbers out of further testing. But for now, I would follow in my day-to-day business the rule 1 million metric points is roughly 20 megs, right? But I think by the points that I mentioned earlier, there is a way for improvement here. I mentioned earlier, interesting, I think I'm missing 2 slides. Yeah, that's part of the QA. No, it's not. Further readings on the topic. Brad Adams and Chris Younger did something for Perfmon, right? They especially looked at Perfmon data and basically hit similar problems, right? Max meta entry, strings data, rolling buckets, etc. Where's to take a look? It's on LinkedIn. Beside that, the metrics channel on the Splunk community Slack. It's always good for discussion. I'm there. Lots of other people are there. Let's share findings and improve all together here, right? I added 2 more things on the QA, which I prepared, and I have a Splunk instance running to show you my findings for now, right? So DB Inspect is one of them. You might remember, if you've seen my talk at SplunkConf this year, how to calculate compression. So that's not rocket science here. You basically take the available values of size on disk and B out of that DB Inspect out of that DB Inspect command, and the raw size. I calculate both into max here. Then I calculate the compression out, right? And that's it basically. And how that looks like is basically, yeah. So that's a talk on SplunkConf. So here's the DB Inspect query, right? My index was called metrics A. I do the compression calculation here, and you can see that, for example, the compression here was around 94%. I have about 27 million events now in that particular index. They have a raw size on disk in max, the raw size of 585, and non-clustered, as said, this is roughly 550. Just to let you know, my other test runs are available here as well. Look at this, right? 770 is compression, so 1 gig ends up with 7.7 gig on disk. That's really bad, right? And has obviously massive impact, 7 times or nearly 8 times as much, right? And you see as well my setup, host count, right? There's the data is available, and it's actually, I can query it quite fast, just to be precise, right? It's just about compression and disk utilization here. Then there's a second one. Going back here. Then there's a second query that might be really useful. I just copied it in. Honestly, just steal it from the monitoring console. There's just one important bit that I need to make you aware of, because I haven't found it inside the REST API documentation. This small setting here that is called data type all, that's needed if you want to see the REST, the configuration and utilization by the REST API for metric indexes. If you don't put that in, you will only see that for log indexes, right? So the output for that one is basically, here we go, right? I cut out some stuff that I didn't require, right? But basically, here you get for I have 2 different indexes running, because I was testing as well with max data size auto and auto high volume. That's why I call it like this. You see all the settings, but you as well see stuff like current utilization, right? Event count, etc., right? Quite useful to build your own dashboards in order to monitor your utilization, etc. That's pretty important. As you see the other tabs online here, indexes conf, you get all the settings for metrics, right? Especially if you just search for metric, you get these couple of settings which are metric specific, right? Come on, metric. I should do metric dot. Here you go, right? There are a couple of settings which are starting with metric dot, for example, metric hot buckets, metric split by index keys, etc. Have a read. Don't apply anything in production straight away. Have a discussion, have some testing, right? Going quickly back here. That's basically my today's talk about Splunk metric indexes. As said, I'm still not in the beginning, but in the middle of testing with it. But from a utilization point of view, from using metric data in Splunk, it's just awesome, right? I used metric data all over the place these days, especially querying them on dashboards, right? Combining them with log data. It just works. It's really quick compared to logs. And it's always worth to transform log events into metric events, independent of that compression discussion here, because I was assuming that lots of people have a collect D or stats D agent out there, right, and shoot from thousands of hosts lots of metric data into the system. But if you're looking into just transferring smaller logs in or smaller volumes of logs into metrics, that might not hit you. As said, I'm available for any discussion on Slack. And I will be as well during the live broadcasting of this year, available via chat. Hit me up. Thanks a lot for listening. Have a great time, and talk to you soon. Thank you.